Please pay attention. Pay attention. So the question says, the new Gauteng number plate has two letters from A to Z, but not using the vowels. Okay? So you can't use the vowels to on the number plate, right? Two digits from 0 to 9, and then another two letters excluding the vowels. So you have got two letters at the beginning, but no vowels. Then you have got two digits in the middle, and then another two letters at the end. Right? So the first question says, how many possible combinations can be created of this number plate? All right. I'm sure you're all aware that we have got 26 letters on the English alphabet. Okay? If we subtract the vowels, we'll end up getting 21. Okay? And then, in terms of our digits from 0 to 9, that will be a total of 10 digits. So, if we want to do 4A, we have got 6 positions. Okay, the first two can be taken by the letters. Okay, now in this case, the question does not specify whether the letters can be repeated or not. So the assumption that I'm going to make, it's very much possible that you can repeat a letter. So we are going to work with a repetition case. Okay, the question was supposed to specify if the letters can be repeated, but from what I know, on a number plate, you can repeat some letters. Okay, so the first position can be occupied by all 21. Okay, the second position can also be occupied by all 21 letters. All right, then like example, you can put a G here, you can also put a G there. All right, then the two digits now. The first position can be occupied by all 10. And the second position can also be occupied by all 10. We are talking about the digits now. Right? Then the last two letters, since the repetition is allowed, you can put 21 there, and you can also put 21 there. Okay? So in total, we just have to use the fundamental counting principle. Remember, this is 4A. So the number of combinations it will be equal to 21 to the power of 4. What is 21 to the power of 4 times 10 squared? 194. 194? 48. 100. Like that. So that number is 194,480. Hey, listen, I'm a specialist in numbers. Yes, am I not supposed to make a mistake? I made a mistake. Okay, this is 19,448,100. Okay. All right. Yeah, I've seen the digits as being 9 of them instead of what? 8. I made a mistake. Okay. All right. Then B. Now B says the previous Gauteng number plate had 3 letters from the alphabet A to Z, but not using the vowels. Then 3 digits from 0 to 9. Are there more combination of the old or new number plates? Okay, let's verify this. Okay, so the previous number plate, it still had 6 positions, but the first 3 were occupied by the letters, the 21. So you could have 21 here, 21 there, and then 21 there. Then the last 3, you could have the digits. You could have 10, 10, and then 10. Then you use the fundamental counting principle. So here, number of old number of combinations old number plates. Okay, so this would be equal to 21 cubed and 10 cubed. What answer do you get?
9,261,000.
What?
9,261,000.
9,261,000. Like that.
Yeah.
So, what conclusion can you make here? What's the conclusion? What's the conclusion? Therefore, the new number plates have more combinations. Okay, because we got 19,448,100. Now the old number plate had 9,261,000. So the new number plate has more combinations. I think this is the reason why probably they might have decided to change them, because people are buying more cars, so they would need to have more number plates. Hey, can you close that? Okay. Any question? Any question here? All right. The next question. The next question. All right. Now, sometimes some questions on the counting principle are very difficult for you to be able to count what's being described. In that case, we work more like backwards. Okay. What do I mean by that? Now, remember here, I gave you this question. Now, in order for you to be able to do this question here, you probably need to know what I'm just going to share with you now. I gave you so that you can try it out and apply what you understood. Okay, so sometimes you might need to determine your total in the sample space. Okay, then you determine what's not described. Okay, now if something is not described, then you say it's N not A. Okay, in that case, it can be easier, like in this example, as I will show you just now. Okay, so we can determine the total in the sample space, and then we can also find what's not described in the question. Then you do a subtraction. So what this means is your NS will always be equal to the number of elements in A plus the number of elements not in A. Okay, and this now we can make NA, so this becomes NS minus N not A. Okay, now the next example which the next question which I also asked you to do over the weekend, like it will require you to use this concept because it's a little bit more complex. Okay? Okay, the basic idea is if you read the question, you need to determine the total number of all possibilities. Alright? Now if you're asked to describe a specific possibility, a specific favorable outcome, sometimes it can be difficult to find this directly. So what you do in such a case is find the opposite of what you want to find. Like in this case, we're supposed to find, you see, for 5b, you're supposed to determine the numbers that will be divisible by 5. Okay? That's not very straightforward. Did you do the question? Huh? Yeah. So, this NA here is like the number, then the numbers that have got a 5, or the numbers that can be divided by what? By 5. Now, to find it, it's a little bit complex. So we have to determine all the possibilities with no what? With no number which can be divided by 5. And then we subtract, yes. And then we subtract it from the total in the sample space. It will be much easier to do it that way.
So the number of factors
yes. And then you can. It's much easier to determine your total in the sample space, okay, and also to determine the numbers that cannot be divided by 5. And then you subtract. Okay, I'm going to show you now. But before I go to the example, do you understand the concept? Finding this directly here, it is possible, but sometimes it can be very what? Very challenging.
Can you use the example of the 21?
No, I'm going to use that as an example. No, we can't use that with the question of the number plates now. That's a different question from this. Okay, so can I have your attention? So this question says, given the numbers 0 up to 5, how many 4-digit numbers can be formed if the first digit may not be a 0 and the numbers may not be repeated? Okay, so 5A, we have got 4 positions. Okay, now I'm going to write down my digits here. So we've got 0, 1, 2, 3, 4, and then 5. We are told in the question that the first digit may not be a 0. So how many digits are left?
4.
Huh?
5.
It will be 5.
Oh, yes.
Remember, in total here we have got 6 digits, isn't it? So if the first digit cannot be a 0, means you are going to end up having what? You are going to end up having 5 here. Okay? But numbers may not be repeated. So if I put a number in the first position here, I can't repeat it here. So how many are left from the 5?
5.
From these 5 here, how many are left? Please answer my question. From these 5 here, how many are left?
But so you still
wait.
0.
Yes, wait. So there are 4. But the 0 now can be put in the second, third, and fourth position. So it will be what? It will be 5. My question was, out of these 5 here, how many are left? Right? So the second position, you can put 5 digits, including the 0.
And now you have to take
Right?
When it says the number cannot be repeated,
Yes.
but find the point of the same number.
The 0 cannot be put here. If we would put a 0 here, then we're supposed to put 6 here.
Among this, not the second point, the number cannot be repeated.
Alright. Okay. But if you have got 5 digits in the first position, you put 1. How many are there? 4.
Yeah.
Plus the 0 which you didn't put in the first position. So that will make them what? 5. Are you following?
And then the next one is 4.
Right? Then you end up with 4 here. Then what? 3. Then you use the fundamental counting principle. Okay? So number of the 4-digit numbers, which will be equal to 5 squared times 4 times 3. What answer do you get? You get 300. That's it. Hey, can you have one lesson? Then B now. B, it says how many of these numbers will be divisible by 5? Okay. Now, first thing, if a number is going to be divided by 5, which digits are supposed to be at the end?
5 and 0.
5 and 0.
So,
okay? Yes.
My question is, when they ask how many of these numbers will be divisible, are we talking about the 300 that we got from the previous answer?
This 300 here, that's the total number of 4 digits. This will be our NS.
So what numbers are we talking about? They are talking about those 300 numbers.
Among these 300 here, how many of them can be divided by 5?
Yes, so that's why I'm asking, are we using the answer for 5 8?
Yes, I'm gonna use it. Okay,
So
so
if your answer is wrong, then what?
if this is wrong, then you won't get B correct unless if you figure out another method. Okay, all right. So here, and I have your attention. And I have your attention. I'm going to try and determine the numbers or the 4-digit numbers that cannot be divided by what? By 5. Then I'll do a subtraction from the 300.
How can you do that?
Okay, I'm going to do it. Okay, listen. I'm sure you can agree with me that if our digit, if our 4-digit number is not going to be divided by 5, it can't have a 0 here, it can't have a 5, isn't it? So how many are left? 4. It will be what? 4.
4.9.
4 from these 6. We can't put a 0, we can't put a 5. So there are only 4 possibilities in that position.
Okay, so basically we are using 300, but also those numbers that we given.
Yes. Remember, we are still using these digits.
Confusing.
Okay, look here. If you don't want a number, rather a 4-digit number, which can be divided by 5, it means the last digit must be a 1, a 2, a 3, or a what? A 4. So
Why did you put 4 spaces?
So we've got 4 possibilities.
Why did you put 4 spaces for B?
For what?
For B, why did you put
0 can be divided by 5.
Yeah, because the question is still talking about a 4-digit number.
So
I'm not sure. I'm trying to understand what's the issue here, because this question here is talking about a 4-digit number or 4-digit numbers
So
that.
there's 4 places.
Yes, so there are 4 places.
I understand. So, B is the question that's confusing. So
Yes.
you're asking,
Okay. The best way to work with, you can't start with the first digit. You start dealing with what? With the last one, because the last one is the one which determines whether a number is going to be divided by 5 or not.
so my question is, okay, if I have 4 spaces, are we still trying to find from those 4-digit numbers a number that can be divided by 5?
Yes.
So like a code or whatever,
Yes.
that code, but it can be divided by
Yes.
5.
Yes. Now, once you put a 4 here, right, we now go to the first position. Okay? We can't put a 0 here, remember, but we can put a 5. So if I put one of these 4 here, how many are left?
4.
Please, can you answer the question?
3.
Don't go two ahead.
3.
Out of these 4 which I wrote here, how many are left? 3, right? But you can put a 5 here, you can put a 0. So this position can be taken by what? By 4.
But I'm not. Still, sir. It's
Let's do it step by step. Let's do it step by step. Let's do it step by step. Okay? Are you following? Right? Then, once you put a digit here, how many are left?
3.
4.
3.
4.
But what about the 0?
4.
So we can put what? We can put 4.
And then it's 3.
And then it's what? 3. Then you use the fundamental what? Counting. Now remember, what I'm trying to determine here, it will be n not divisible by what? By 5. Times 3. What answer do you say? 72. You will get it? 72.
So it's 196.
That's one of the wrong things.
192.
So
Yes.
could you not have done it the other way around and put 5 and 0, which is going to make 8 and then just 5 and 5.
You have to, in this case, you have to start dealing with the last
That's what I'm
position.
saying. If you put 0 at the last one, then 2 for the last number, and then 4.
Which two are you talking about? No, remember, okay, what am I trying to define?
Okay, wait, sir.
Alright, I need to carry on. So,
My question is, could you not have found the numbers that are random, like asked to go by five?
it's not that simple, it's not that simple as you think directly, it's not.
Can you not just put two because
No,
zero and
no.
five?
Okay, you do it and see if you can get 192. Do it then.
Why would it be 192?
What?
Because that's not. So I want to find it.
Yes, so I'm gonna do that now. Numbers, so numbers,
It's going to be 30. That's
divisible by 5, this will be equal to 300. See this 300 here minus 192. Then you get 118. It's not that simple to get that 118 directly.
196.
Yeah. So if you try to use another method, you'll find that it's gonna be very what? Difficult. Okay, this will be the easiest method. If you practice a lot in the next coming weeks before your examination, if you encounter a question like this will be the best method to approach that question. Yes. If a number can be divided by 5, it must have a 0 at the end. Or it must have a what? 5. Any number which has got a 0 at the end is divided, can be divided by 5. Any number which has got a 5 at the end can be divided by what? By 5. Like for example, if I give you 325, right? And then if I give you 300, or if I give you 10,000, or if I give you 10,000, 5 by 5. So if a number can be divided by 5, it must have a 0 at the end or a 5 at the end. Alright. Are you following? Okay. Let's talk about another aspect. Now, sometimes, can I have your attention? Sometimes